All right, welcome to our next video on triangles. Today we're going to focus on inequalities that we see. So when we make comparisons, what are some things we're going to notice in these different triangles? Okay, the first part of our notes, we're just looking at different side lengths. And so the general idea is the sum of the lengths of any two sides should be larger than the third side. This is probably one that you're somewhat familiar with. As you fill that in, specifically the thing that we're looking for is when we look at the two small sides and we add them together, are they bigger than the third side? So let me show you a quick little visual of that. Okay, so here I just have a triangle. I've measured the sides, and as I move these things around, you can see the measurements are changing. This is clearly our big side right now. And what we want to do is just be checking that the other two sides, if I add those together, so here I'd get about 17, 18 total, are they bigger than that third side, than that large side there? In this case, they are. And every time that I do that, okay, it should work out. Okay, I can even change this so now I have a different big side. Now this is the big side. So now I'd really want to check these two sides and make sure that they are larger than 15, and they are. Okay, so that's just something kind of just a good fact for us to know. Okay, when we think of other relationships that we're going to notice here, as we look at any triangle, if we've measured all the sides and all the angles, one thing we'll start to notice is that the big side is going to be opposite the big angle, and the small side is opposite the small angle. So again, I want to show you a visual of that. So as you copy that down, go back to this. Switch screens a second, go right down here. Okay, so it's kind of the same thing, just more measurements. So now I'm noticing that I have some angle measurements in here as well. I've tried to line them up a little bit. So we just look at this first one. This is the big angle, and the side that's opposite it is AC. And if you look at the measurements here, those are the two big ones. They're opposite each other. Okay, when I look at, now if you notice these two angles are about the same. Okay, but if I look at the smaller one, angle A is 42 right now, and the side that's opposite it is just a little bit smaller than this one right here. So the small ones are opposite. I could exaggerate that here just a little bit. Okay, so now this is that small angle, that's the small side. This is the medium angle, that's the medium side. And this is the large angle, that's the large side. So again, just something that we should be aware of as we're looking at different triangles. Okay, and then the last thing is kind of a extension of Pythagorean theorem. We're pretty familiar with this. When C is that big side, when we see that C squared equals A squared plus B squared, we know it's a right triangle. So what happens when that's a little different? So I'm going to go to a different sketch for that. Okay, right here. So what I'm showing you here is a lot of measurements going on here, but first thing is just notice it's basically a right triangle. I couldn't get it to be exactly a right triangle. Okay, but over here I've measured all three sides, just so you know. That's my A, B, and C, lowercase a, B, and C. And then I squared them. Okay, so we're going to focus mainly on those measurements. And then once I squared them, I also took A squared and B squared, added them together. Okay, and so if you look at those, they're basically the same right now. If I could get this angle to be exactly 90, these would have been exactly the same. But that just kind of shows you that what we had the first time is true. When A squared plus B squared equals C squared, we have a right triangle. Okay, and so what we're going to do is we're going to modify this here just a little bit. So right now, based on this angle here, this is an obtuse triangle. And if I go through and I think of A, B, and C being the same thing, I still measure those sides, I still square them. And now I look at these comparisons. Notice that C squared is now larger than the A squared plus B squared. Okay, so that's one thing we might notice in any obtuse triangle. Wherever I stop it here, as long as this angle is bigger than 90, I'm going to notice that the C squared is bigger than A squared plus B squared. Okay, if I made it an acute triangle, so let's make that angle less than 90 now, and then I have to check these two angles as well. They're still less than 90. Okay, so it's an acute triangle now. Now when I go up here and I compare the C squared to the A squared plus B squared, notice that A squared plus B squared is now larger. Or another way of saying that, probably a better way of saying that, C squared is smaller. So that can help us determine what's going on in our triangles as well. Okay, so when c squared was greater than a squared plus b squared, we saw it was an obtuse triangle. And when c squared is less than a squared plus b squared, we saw it was an acute triangle. Okay, so I want to run through an example that just kind of shows all three of these rules in your notes, just so you have something written down. Okay, so if we're looking at this example right here, you can see that I'm just going to go through rule 1, 2, and 3 in our notes here. You can see how much space I'm going to use. You can feel free just to let me talk for a little bit, and then you pause the video and copy some things down. But first one for rule 1, we're just kind of trying to make sure that the two small sides are indeed, the sum of them is indeed larger than the third side. So I just kind of set this up. I say my two small sides are 4.9 and 7.05. I don't know how they compare right now, but I want to make sure that they're going to be larger than 9.18. Okay, so I go ahead and I add those together. I get 11.95, and yes, they are greater than 9.18. So that just shows me that these three sides could make up a triangle. A lot of times they would say, here's your three sides. Could it determine a triangle? We wouldn't have the picture for that. Okay, for rule 2, this is the one where we just kind of notice what's going on, opposite angles and sides. And for this one, all you have to do is check the picture. Okay, so if I go down here, 32 degrees, that is the small angle. Opposite it is 4.9, that's the small side. This is the big side right here, 99 degrees, or big angle, 99 degrees. Opposite that is the big side, 9.18. And that means the other two would kind of be in the middle, so 49 is that middle angle, 7.05 is the middle side. Okay, rule 3 is going to be where you have the most work. Remember that we do want to have that big side be the c, so we're going to say c squared, 9.18 squared. Okay, so I set that up, 9.18 squared. I don't know how it compares to the sum of these two parts, but that's kind of the question. So now I just have to use my calculator, square these things. And in this case, I am getting some larger decimals. That's okay. Again, I have this question mark here because I don't quite know how it compares, but I'm trying to figure that out. Okay, I add those two sides together right here. I get 73.7125. Now I can make that comparison. Okay, it's the 84 is greater than 73. And whenever I saw that c squared was bigger than a squared plus b squared, that made it an obtuse triangle. We can see that that's true, right? This angle right here is greater than 90, so it is an obtuse triangle. Okay, so this whole page was based off of comparisons we see in one triangle. So we just want to make sure that that makes sense right now. If there's a last example on your note page, we're going to cover that in class together. And if you flip the page over, we're just going to look at one rule that talks about inequalities when we see two triangles. So this is called the hinge theorem. It's when we have two triangles that have two pairs of sides that have equal length. And so I kind of like this image that I found. Some people call it the alligator hinge maybe. And so if you look at the jaw of this alligator, okay, this red length, it's the same in both of these alligators, right? It's the same alligator really, it's just opening its mouth. And so the blue lengths are also the same. And so what this hinge theorem is saying is that the triangle that ends up with that included angle, a larger included angle, is going to have a larger third side. So we have to think, what does included angle mean? It means the in-between angle. So right here, in between the two sides that we know. That's what we mean by included. Okay, so this obviously has the bigger angle right here, and it's going to have the bigger third side. Okay, we could go in reverse as well, the triangle with a larger third side. So this side right here is bigger. That means this angle here has to be bigger when we compare it to the other triangle that we have. This only works when the two triangles have the same pair of two sides, and then we can make this other comparison. This one's a little bit more complicated. So we'll look at two quick examples, and then we'll save a more complicated one for together in class. Okay, our first example, they're giving us a little bit of info here. They tell us that within these two triangles, that these two are the same length, top and bottom are the same length. Notice that they also have a shared side right there. Okay, so that's kind of our two pairs of congruent sides. We have that met. Then they're giving us some info about the third side in each triangle. So this is just a little bit bigger than this. And so they're asking, how does angle PST compare to angle SPR? So PST is right here, angle that's kind of right in this spot. And SPR, go from S to P to R, it's the angle that's right there. Well, the idea here is that since this side is bigger, than the 23 over here. The angle across, so this angle right here would have to be bigger than the angle across right there. Okay, so we'd have to say angle PST is larger than angle SPR. Okay, our last example in the video. Okay, it's kind of similar. Okay, they tell us that two sides are the same right here. Again, they have the shared side right there, but the difference is now they're telling us something about the angles, the included angles. Okay, and so we need to figure out how does JM compare to LM. So JM is right there, and LM is right there. Well, since the 64 degrees is the bigger angle, and we find the side across from it, JM would have to be the bigger side compared over here with the small angle. This must be a smaller side. Okay, so we're going to pause right there, stop right there, and we'll pick this up in class the next time we see each other. Have a good rest of your day.